Okay, I think I showed this to you, the writing PEMDAS with 2 letters per line. This can help you to remember your properties of exponents. When you see parentheses, you multiply the exponents. When you see multiplication, you add the exponents. When you see division, you subtract the exponents, assuming, of course, that it's the same base. So our first property that we learned was if you're multiplying with the same base, you add the exponents. Today we're going to look at an example of that with rational exponents. So instead of 3 squared times 3 to the third, now we're going to look at 3 to the 1/2 times 3 to the 3/4. And we would do 3 to the 1/2 plus 3/4. To add fractions, you have to have common denominators. Some of you are very good at seeing that 1/2 is 2/4 and then adding 2/4 and 3/4 together. Some of you look at fractions and get like that skin crawly feeling on the back of your neck. So if you are in that category, grab your calculator and let the calculator do the work for you. If you have a graphing calculator, there are fraction features on the graphing calculator, but depending on which model you have, it may or may not work properly. If I could get my calculator to turn on. So to add 1/2 and 3/4, parentheses, 1 divided by 2, close your parentheses. You just entered the fraction 1/2 into your graphing calculator. Plus, parentheses, 3 divided by 4, close your parentheses. Now, if you hit enter right now, you're going to get a decimal for your answer. And you don't want a decimal, you want a fraction. So before you hit enter, push your math button. And then see that first option, change to fraction. So I entered 1/2 in parentheses plus 3/4 in parentheses and then entered change to fraction. And my graphing calculator tells me that the answer is 5/4. So this is 3 to the 5/4. Now, what if you don't have a fancy schmancy graphing calculator? If you have a scientific calculator, kind of like this one, here's how you would do this. Okay, we're supposed to do 1/2 plus 3/4. On this calculator, your ABC button, you want to use your ABC button. So 1 ABC 2, there's 1/2, plus 3 ABC 4th. It was 1/2 plus 3/4, right? Okay, and hit enter, and it tells you 1 1/4. Now, the problem is we don't want mixed numbers, we want an improper fraction. Right above your fraction button is the option to change it from mixed number to improper fraction. So, second fraction button, enter, and it tells you that the fraction is 5/4. If you have a scientific calculator different from this one and you'd like me to help you learn how to do fractions on your calculator, please let me know. I would be happy to help you with that. After you've used the property to simplify, I want you to check your perfects chart. Remember that the denominator tells you that this is a 4th root. So check the 4ths column, see if 3 is in your 4ths column. Is there a 4th root of 3 that is a whole number? 4th root of 3? No? Okay, so we can't do the 4th root of 3 without getting a decimal, so our answer is done. Oh my gosh. All right, let's try the next one. The property says if you've got exponents broken up by these parentheses, you multiply the exponents together. So we are going to do 4 raised to the 3/2 times 2. And again, you can use your calculator for this, or if you remember that whole number 2 is 2/1, multiply numerators and denominators. This is 4 to the 6/2. What is 6/2? 3. And now use your perfects chart to figure out what 4 to the third is. Start at 4 on the left column, go over to the thirds column. 4 to the third is 64. The next one. We're actually going to be using this property backwards. during our other examples. But if you have things that are being multiplied inside the parentheses, raised to an exponent on the outside of the parentheses, that exponent applies to both of the things inside the parentheses. So this becomes 9 to the 1/2 times 4 to the 1/2. Remember that an exponent of 1/2 is the same as a square root. So what is the square root of 9? And what's the square root of 4? And 3 times 2 is 6. Negative exponents still move even if it's a rational negative exponent. So 25 to the negative 1/2 becomes 1 over 25 to the positive 1/2. And what did we just talk about? An exponent of 1/2 is the same as a square root. The square root of 25 is 5. So this becomes 1/5. The next property says that if you have the same base and you're dividing, you subtract your exponents. So in this example, we are going to do 6 raised to the 5/2 minus 1/2. If fractions give you the heebie-jeebies, you should probably deal with that so they don't anymore, because fractions really aren't that bad. But if they do give you the heebie-jeebies, grab your calculator and do 5/2 minus 1/2. If they don't give you the heebie-jeebies, 5/2 minus 1/2 is 4/2, and 4/2 is the same as 2, and 6 squared is 36. Number 6 is very, very similar to number 3. If you have division inside the parentheses raised to an exponent, you can apply that exponent to everything inside the parentheses. So this would be 8 to the 1/3 divided by 27 to the 1/3. Check your denominator of the fraction. The denominator is the index of your radical. So 1/3 is the third root. Look in your thirds column. Do you see 8 in your thirds column? Yes, 8 is in your thirds column. 8 is in your thirds column. The third root of 8 is 2. 27 is also in your thirds column. The third root of 27 is 3. So this becomes the fraction 2/3. Okay, in these examples, some of them are kind of like a puzzle. So it may not always be readily apparent what you should do. You might have to try something else. But eventually you should be able to get the simplest answer. The first one, notice it's the same base, and we're multiplying. So what do we do with the exponents? Add them. We're going to add 1/2 plus 1/3. So, using your calculators, 1/2 plus 1/3. Ooh, that got really small. 1/2 plus 1/3. Change it to a fraction. 5/6. So this is 6 to the 5/6. Now I want you to check your perfects chart. When you think you're done, check your perfects chart. Usually you are done, but sometimes you'll be able to simplify it further. So check your perfects chart, start with your denominator. This is a 6th root of 6 raised to the 5th. So can you do the 6th root of 6? Check your 6th column for 6. Do you see 6 in your 6th column? How many 6s did I just say in the last sentence? Lots of them. 6 is not in your 6th column, so you cannot take the 6th root of 6 without getting a decimal, so our answer is done. The next one. What do you think we're going to do with the exponents in the next example? We multiply. When you see parentheses, you multiply the exponents. So 6 to the 3/4 times 2/3. You can either do this in your calculator or you can do this on paper. Multiply the numerators multiply the denominators. 6/12 is 1/2. Check the seconds column. Do you see 6 in your seconds column? No, we can't do the square root of 6 without getting a decimal, so 6 to the 1/2 is our answer. All right, next page. This one, do you notice that they're not the same base? So we can't add the exponents because it's not the same base. When you see that happen, the first thing that you should try is do either piece of this, can either piece be simplified? So can we do the third root of 3? No. Can we do the third root of 27? Yes. The third root of 27 is 3. And a plain 3 is 3 to the first. So we have 3 to the 1/3 times 3 to the first. Now we have the same base, so now we can add those exponents together. Again, you can use your calculator for the fractions, or many of you know that 1 is the same as 3/3. So this is 3 to the 4/3. Again, check your denominator. Can we do the third root of 3? No. So that's our answer. Number 4, we're dividing with the same base. So we subtract the exponents. 1/4 minus 3/4. Your calculator will tell you that that is 5 to the negative 1/2. Do you suppose that we can leave our answer with a negative exponent? No, definitely not. So this is 1 over 5 to the positive 1/2. We can't do the square root of 5, so it's done. Next, number 5. Do you notice that in number 5, the bases are not the same? So the first thing you should check is, can we do the 5th root of 48? No. Can we do the 5th root of 12? No. Okay, so that tactic didn't work. Do you notice that they both have the exact same exponent? So why don't we put 48 over 12 back into the parentheses and put that 1/5 outside of the parentheses? We just use the property backwards. We have a property that says if we start with this, we can break it up into 48 to the 1/5 over 12 to the 1/5. We use the property backwards. But now we can do 48 divided by 12. What is 48 divided by 12? 4. So our answer is 4 to the 1/5, which is a whole lot simpler than what we started with. Number 6. There's 2 ways you can do this. I noticed that inside the parentheses, we're multiplying with the same base. So I am going to start by doing 6 to the 1/7 plus 4/7. What is 1/7 plus 4/7? 5/7. Then we need to raise that whole thing to the 6th. Now we need to multiply those exponents. So multiply 5/7 times 6. 6 raised to the 37ths. How you would ever get that in an actual problem, I have no idea, but whatever. Okay, our last problem is actually very, very similar to number 5. Okay? So when I see this, I think, oh my gosh, not the same base. I can't add or subtract exponents if I don't have the same base. So I look at the denominator. These are all 4th roots. Try the 4th root of 10, not on the chart. 4th root of 24, not on the chart. 4th root of 15, not on the chart. But because they all have an exponent of 3/4, you can put the 3/4 outside of the parentheses and inside 10 times 24 divided by 15. What is 10 times 24 divided by 15? So we have 16 to the 3/4. Now, before you're done, check your denominator. What is the 4th root of 16? The 4th root of 16 is positive or negative 2. Raise positive or negative 2 to the 3rd, and your final answer is positive or negative 8.